Chapter number 4, data structures. After arrays, non-primitive data structures, primitive data structures, there after arrays we are going to one more new data structure, that is stack. See dear student, as the definition says of the stack is an ordered collections of data items. Ordered collections of data items, okay, where insertion and deletion will take place at common end. Insertion and deletion will take place at common end, same end. That end is called as top end. That end is called as top end. And opposite one more end, that is what we called as base end. So in the data structures, stack is a one type of the data structure. It is having a chance to store the data. It is having a chance to insert and delete a data, but at a common end. That end name is called as top end. See this diagram. See, this is in a one ordered collections of data items in a one particular place. Here two ends are called, that is one is top end and second one is base end. Insertion and deletion will take place at the same end because it is a closed vessel. It is a closed data structure. At another end, base end, that will use it to just store the data items, not to delete. Hence, insertion and deletion will take place at the common end. That end is what we call as top end. By this end only, inserting of elements and deleting of an element will take place. And stack will follow one type of the technology, that is LIFO. LIFO means last in, first out. Last in, first out means which is the last element is inserted and that element will be deleted first. So that is what we call as LIFO, last in, first out. So here the 40 will be the last element inserted. This will become the first element for the deletion. So this is what we called as inserting and deleting at the same end will take place, and the technology is what we called as LIFO, last in, first out. So here also we have some operations. Stack also having some list of operations. That operations are called as stack, push, pop, is empty, size and peek. Or the operations, nearly 6 operations we have in stack. One by one let us discuss the definitions of the operations of stack. Stack is in a same definition, ordered collections of data items with insertion and deletion will take place at the common end. That end is called as top end. Second one, push. Push is an operation of a stack, inserting of a new element to the data structure. Inserting a new element to the stack, that is what we call as push. Pop, deleting. Pop means removing, deleting an element from the stack. Deleting an element from the stack. Is empty. Is empty means whether the stack is empty or not. Checking the stack whether that is an empty or not. Is empty. Is means always questioning. Is empty. Is empty or not. Whether the stack is empty or not. That operation. And size, number of elements inside the stack. number of elements inside the stack, total number of elements inside the stack. And also peak means high, top. So what will be the peak element of the stack? So this will be operations of the stack. Now we are going to move very important concept, algorithms. For your examination, so many times this question will be asked. Write an algorithm for push and pop of a stack of data structure. So especially push and pop algorithms, or that is in the forms of opposite manner, better to learn these algorithms in the combined form. This will be very helpful for the remembering. So now we are going for algorithms for push and pop. So if I coming to the algorithms of the stack, push and pop are the two algorithms. As you are seeing on the board, push and pop are the algorithm. Inserting of a new element to the stack, that is what we call as push. Deleting of an element from the stack, that is what we call as pop. So in these two algorithms, one common thing you have to understand here, insertion and deletions will take place from the stack to the stack, insertion from the stack, that is deletion. So adding a new element to the existing stack, that is push. Removing an element from the stack, that is what we call as pop. Then we will combine these two algorithms and we should going to learn. See, step number 1, algorithms, as you know in first year, solving a problem step by step, that is what we call as algorithm. In algorithm, first step you should write the name of the algorithm. The push is an algorithm name, and inputs, process, terminations, and all these terminologies you should maintain for the algorithm. So step number 1, it is a one condition. What is the condition? If top is equals to -1. If top is equals to -1 means in the stack, for example, if you are, just assume this is a one stack. See, this is a one stack. Here almost all the elements are inserted into the stack, and the last element is also inserted like this. So the last if condition, top is equals to n-1, this should be the location. That means almost all the elements are inserted already in the stack. If top is equals to n-1 will be the condition. If this condition will be true, print stack is full. Of course, the stack is full. That condition is what we call as overflow condition. Why? Because there is no chance to add a new element to the stack. By seeing this diagram, what you are getting, already the stack is full. We don't have a chance to fill a new element to the stack because this stack is already filled. So that's why this is an overflow condition. Print stack is full, overflow exit will be the one condition. If the stack is already full, we don't have a chance to insert a new element. Then when the stack will accept the new element, it should minimum, it should have a one empty space to add one element, like that. So end of the if condition. And step number 4, if top is equals to top plus 1. If this condition, now it has a chance to add one new element to the stack, because at the last of this top of the stack, yes, one empty particular place is there. Yes, we have a chance to add a new element. Top is equals to top plus 1. Top plus 1 means adding a new element. Then which element you are added? Stack of top is equals to item. The 40 will be the new item added to the stack. See here, stack of top. Now that is the value of the 40. Then what will be the item? 40 will be the item. In which place? 0, 1, 2, 3, 4. In 4th place, this 40 will be added. So stack of top is equals to item is equals to 40. 40 will be the new element added. Then stop. Means here for the one existing stack, we have a chance to add a new element. Before insertion, the total number of the elements in this stack are 1, 2, 3, 4. After adding a new element 40 to the stack, then changing values of the stack are 5. 4 plus 1, 5. So stack will be added, inserted a new element. This is what we call as push. Then coming to the pop. Pop of an element. We should remove one element. Here also we need some diagram. See here also one stack is there. Like that one stack is there. Right. Step number 1. If top is equals to -1. What the -1 indicates? -1 will indicate that is an empty stack. In that particular stack, there is no element. See here, this is a stack. This end is what we call as top end. But in this particular stack, there is no element. Then without element, how you will be delete? It's impossible, right? So that condition we have to show first. See here, step 1, if top is equals to -1, means there is no element in the stack, then print stack is an empty. Of course, the stack is an empty. This condition is what we called as underflow. Overflow means total number of the elements are filled, there is no chance to add a new element. Underflow means we don't have a chance to delete one element. Why? Because there is not even one element is not present in the stack. So we don't have a chance to delete an element from the empty stack. That's why that condition is what we called as underflow. Now, then exit step 3, step 4 end if. Step 4, item is equals to stack of top. Now, if we have a chance to delete one element, that is the element that is a 10, and this end is what we call as top end, because only one element is present in the stack, and that element now I have a chance to delete. Top item is equals to, item is 10 now, 10 is equals to stack of top. So that element I am selecting. Top is equals to top -1. -1 means we are removing that 10th element and we should stop the algorithm. Before deleting, the total number of elements in the stack is 1. After deleting, the total number of elements in the stack is empty because only one element is there. Now I removed that element also. So this is what we call as inserting and deleting an element from the stack. So this will follow the LIFO, last in first out technology. So this is what we called as algorithms for push and pop. Remember dear students, for your examination, for the 5 marks, they may ask individually, write an algorithm for push 5 marks, write an algorithm for pop for 5 marks, like that they may ask. Or also they will combine, write an algorithm for push and pop of an stack for the 5 marks. You have a chances to ask these kinds of the questions. Remember, very important question for the 5 marks. Then after the algorithms of the stack, now we are going for the some applications of the stack. This is also very important for 5 marks. Applications of stack. We are coming to the applications of the stack. So usually they may ask questions like this. Write the applications of the stack. No need to explanation of the applications. Just you mention what are all the applications of the stack. That is more than enough. So these are all the sub applications of the stack. Reversing string. In the reversing of string, we are using a stack. Reversing of string means we are given one word, and by returning that word, that will gives a common meaning. Reversing of string means it will reverse the word meaning. So that's what we call as reversing of string. There we are using stack. Undo mechanism, redo, undo. Undo means again we are coming to the take back to the first positions of the redo. So that is what we call as undo. And backtracking. Backtracking is a type of the process. We are searching a path to come out from the problems, backtracking, and also expressions and evolutions, conversions of the expressions. There also we are using a stack. Tower of Hanoi, it is a type of the problem solving technique, Tower of Hanoi. So there also we are using stacks. And quick sort. Sorting means arrangement of elements either in ascending or descending. Quick sort. So sorting of an element. So there also we are using stacks. So these are all the list of application for 5 marks. Just if you mention the application's name, that is more than enough. So remember, very important question, applications of the stack. Here onwards, now we are going to the one more data structure, that is queue. So queue is also a type of the stack data structure, but here some differences are there. Queue, as the definition says, queue it is an ordered collections of data items where insertion and deletion takes place at different ends. In stack, insertion and deletions will take place at same end. That end name is called as top end in stack. Like that in the queue, insertion and deletion will take place at the 2 different ends, that are rear and front. Insertion is always at the rear end and deletion is always at the front end. So as the name, that is queue, you have a knowledge about queue, whatever the queue, either a queue with a queue in a film theater, queue in a school and colleges, queue in front of the offices, queue, normal queue. What is the mechanism behind that queue? The new person will be added at the end. That end is called as the rear, right? After finishing of the work of that first person, he will exit from one end. That end is what we call as front end. So, deleting at front end, inserting at rear end, that is what we call as queue. Here we will show with the help of one diagram. Assume this is a one queue. Okay, assume this is a one queue. Here, inserting of an element at rear end, inserting of an element at rear end, deleting of an element at front end. 50 is a new element added. After deleting 10, here we have a chance to add one more element. So that is what we call as front end. Deleting at front end, inserting at rear end. Then which is the mechanism? Like stack will follow LIFO, last in first out. Then what is the technology behind for the queue? Queue is FIFO, remember. FIFO, first in, first out. Here in the empty of this particular queue, the first element, added element is 10. That's why this element will be comes out first. First in input, first output. First insert. Okay, the 10 will be inserted at the first and the 10 will be the coming out from the first element. So this is what we called as FIFO, first in, first out. The queue will follow. First in, first out. See? First in, first out. So this is what we called as definitions of the queue, and give one example, and FIFO will be the technology for the queue. Now we are going for types of queue. We have major 4 types of the queue. Let us see one by one. Types of queue. So in the types of queue, the first type of the queue is simple queue. Okay, simple queue. Second one is circular queue. Circular queue. Third one, priority queue. Priority queue. And fourth and final queue, that is double-ended queue. Double-ended queue. Simple queue, circular queue, priority queue and double-ended queue. Now let us discuss about with neat diagrams of all these types of queue with its representations. So if I coming to the types of the queue, after the queue definition and how the representations of the queue will follow, now we are coming to the types of the queue. So as I said earlier, we have a main 4 types of the queue. One is simple queue, second one circular queue, third one priority queue, fourth one double-ended queue. So if I coming to the first type of the queue, that is a simple queue, as the definition says, the simple queue, inserting and deleting will take place at the 2 different ends. Insertion will take place at the rear end. Deletions will take place at the front end. So this is what we called as a simple queue. As the diagram implies, see the simple queue, insertion will take place at the rear end. Deletions will take place at the front end. So in this particular queue, total contents of the queues are major 3 contents. A, B and C are the contents of the queue. Here insertion will take place at the rear end, deletions will take place at the front end. So this is what we called as a simple queue. Then if I come into the second type of the queue, that is a circular queue. The last node of the queue, the last node of the queue will follows the first node. Here the last node is D, will follows the first node, that is by A. This is what we called as circular queue. Means this is a closed type of the queue, will follows last element will follows the first element. Last node of the element will follows the first node. This is what we called as circular queue. Then coming to the third type of the queue, that is priority queue. As the definition says, priority means user needs some priority. This element will goes to the third position. This element will comes to the first position. Like that, we need some priority. So that is why 0 to 3 are the priorities. In the 0th priority, 10, 20, 30 are the elements. First priority 40 and 50, second priority 60 and third priority that is 70 and 80. This means in the location of 0, 10, 20, 30 will comes under the first, and the location of 1, 40 and 50, 2, 60 and 70, third 70 and 80, last element. That indicates user will have a chance to change the locations of the elements. So this is what we call as priority queue. We have a chance to change its location. That means, for example, 10 will become under the first location of the queue. Sometimes I will change, 10 will go to the last element. Yes, on that time, in the place of 3, in the place of 80, if I change the 10 will come at last. Like that, we have a chance to change its location. Then the final type of the queue, that is what we called as double-ended queue. This type of the queue is what we called as at both ends, at both sides, that is rear and front ends are present. Rear and front ends are present. Both the ends, insertion will possible and deletion will possible. That is what we called as double-ended queue. This is the concept, types of the queue. The double-ended queue is accepting both insertion and deletion with both ends. So that is what we call as a types of queue. Now we are going for one more very important concept, that is algorithm of a queue, that is insert at the rear end or delete at front end.